Okay. So, coordinate geometry. Okay. Coordinate geometry is a fairly straightforward subject. It's it's originated it originated in the 1600s when there's this guy called Descartes, French guy called Descartes, and he first thought of combining normal algebra with geometry. Algebra with geometry. So, in the sense that the way we do things in geometry, pre coordinate geometry, or till whatever you have studied so far, 10th grade and all, what we do is we look for properties, we look for theorems, right? And we try to prove things, correct? And we say that uh, by looking at the figure and some assumptions, we can prove many facts in geometry, but we don't write equations, right? When you're doing normal similar triangles or congruent triangles in 10th standard, you don't write any equations, right? Correct.
Yes, sir.
What are you doing? You are basically looking at a problem and you're trying to prove things by just some basic theorems that you know, right? But what Descartes found out is that you can use algebra in that geometry and help that will help you derive many results very easily. Like when once you start using algebra, you can actually solve equations for write curves, different types of curves in different equations, and understand the meaning of a curve in terms of an equation. So what is the meaning of writing an equation for a curve? Writing an equation for a curve. So people might be familiar with curve slash line. So you guys might be familiar with straight line equation is this, right?
Yes, sir.
Yes, sir.
And you
I'm
might also know that x square plus y square is equal to
A
4, for
square.
example,
Yeah.
is a circle.
Circle.
sure.
And this is a straight line. So what is the meaning of all this? Like, why is the algebra equation going to represent a straight line, right? So how
Yes.
did we come to this? Like, can someone explain? Like, how can an algebra equation be a line?
Sir, can I?
Go ahead.
So, what we know is that y and x are basically the coordinates in the Cartesian plane.
So you'll make a plane, two lines you'll make. What is this plane? It's just an intersection of two lines, which are 90-degree, right? And this is y and this is x. And then,
So, we know that, so basically, we're using this equation because it's like a plane.
hmm,
Um, we can actually we can draw a line because of the varying of m and c, and which is basically
M and C are
gradient and y.
constants actually.
Oh wait, sorry, m and c are y and x varying. Sorry, my bad.
Yeah.
Um, based on based on the ratio with m and c,
But how
basically.
can we draw a line? Like, what is the meaning of drawing a line here? Okay, I can draw any arbitrary line. But then,
So we know m and c. M
hmm,
is the gradient and c is the y-intercept. We know that.
hmm,
So because for with that we can um, pair, because m is multiplied by x. We can pair it with multiple values of x to derive
hmm,
the y pair for the same for that x value.
correct. So, but before you say that, you should say that the meaning of this Cartesian plane is that you point out a origin. The point of intersection of the straight lines is called the origin, and every point in space has a particular x value and a particular y value, right? Like every
Yes, sir.
point in this coordinate plane is basically a ordered pair of numbers. Ordered pair of numbers. That means the first number in this pair will denote this perpendicular distance, right? And the second number will denote this perpendicular distance, correct?
Yes,
So
sir.
once you have that, any point you can say perpendicular distance from y axis is this much, so that will be its y coordinate, right? And perpendicular distance from x axis is this much, so that will be its x coordinate, correct? And that is how
Yes.
you will write it as 6,8, let's say, right? That means this distance was 8 and this distance was 6. The figure is wrong, but whatever, right?
Yes, sir.
Yeah.
So only then can you start saying that, okay, if there are 2 points, then I can join them and this should be a line, right? If there are 2 points in the plane, I can join the 2 points and it makes up a line. And then I am trying to now find the relationship that any x1 and y1 and x2 and y2, what is the relationship between y1 x1 and y2 x2, right? That relationship is basically y is equal to mx plus c, right?
Yes, sir.
So basically what we are saying is that any point that satisfies this equation lies on the line. Satisfies this equation will for sure lie on the line. Correct?
Yes,
sir.
sir.
And any point that does not satisfy this equation, right? Any point that does not satisfy this equation will not lie on the line.
Lie on the line.
So that is the meaning here. And the reason why are we using equations, like earlier also in geometry also you used to know that, okay, fine, if there are 2 points you can draw a line through them. You could do many things using your normal basic properties and all, right? Geometry theorems and stuff. The
Yes,
reason we are
Euclid, yes,
the reason we are using these equations is because geometry problems can be hard. Okay, it is difficult to prove many things sometimes. Like in geometry, it takes a little bit of imagination and creativity to prove things. But algebra is considerably easier, no? Like algebra is solving some equations, right?
Yes, sir.
yes, sir.
So,
Equate
so
them.
if you know the equation of this line, then if I know equation of this line also, I can find this point, I can find this angle between two lines. I can understand the whole geometrical setup using algebraic equations, which makes the job much easier, at least for normal people, right? So
Yes, sir.
that is the whole point of the subject. What we will start off with, however, is different ways of representing points in the plane. So we'll see two ways: normal Cartesian coordinates, and the second one is polar coordinates. Polar coordinates. Okay. So both of you know already what is the meaning of Cartesian coordinates. Any point in space can be written as x comma y, and this distance is y, and this distance is x, right? These are perpendiculars on the axis. This is y axis, this is x axis, correct?
Yes, sir.
So the same point can be also represented in this way. If there is an x comma y, you can say that it is at a distance of r and at an angle of theta, right?
Yes, sir.
Yes, sir.
This distance is r and this angle is theta. Notice that knowing both the values of r and theta will definitely fix the point for you, right? Like it will not be that point is unknown after you know r and theta, right? Because theta will tell you what is the angle at which you have to go, and r will tell you how far you have to go, right?
Far you have to go.
And
Yes,
sir,
sir.
show one point which is in between, so it becomes easy.
What?
So we're taking it from the origin, right? So
Yeah. We are
we know
taking everything from the
theta
origin.
and the
So
distance we can find it.
distance is known. So if only r was known, we would have many infinite points like this, right?
So it would become a curve.
It will become a circle if r was fixed, right?
Yes, sir.
However, if you know the angle also, then only one of those points should be marked, right? Correct.
Yes, sir. Only one point.
So x and y is a Cartesian method of talking about the same point, and r and theta is the polar coordinate method of talking about the same point. Okay. So what is the connection between them? So suppose you have been given 2 comma 4. How will you find the r theta for this, right? Suppose 2 comma 4 is this point. I mean want to find the r theta form of the same point 2 comma 4, right?
So R, so we can use Pythagoras theorem.
It
So
will
r
be
you
root
can
of
use
So
root
2
of
square
20,
plus 4 square.
right?
Yeah.
Root
Yes, sir.
20 is r. So basically this is 2, this is 4. So tan theta should be 4 by 2, right?
Yes, sir.
So tan theta is 2.
2. Tan theta is 2. So theta. So when you don't know the angle, the way you write it is
Tan
theta is
inverse
equal to
2.
tan
Tan
inverse
inverse 2.
2, right? This angle is not known to you right now. You will have to look up some tables, right? There are trigonometric tables which will tell you the angle, or you'll have to calculate it using trigonometry or using a calculator, right? So for now, just to write it, you will write it like this: tan inverse 2. Tan inverse 2 means basically the angle whose tan theta is 2. Dave, are you understanding?
Yes, sir. I know.
So this is how you represent this point, right? So the connection between the two coordinate systems is fairly obvious. So basically, r theta and r is equal to root over
Root over
x
x
square
square
plus
plus
y
y
square,
square.
and
And tan theta is y by x.
and you can also say x is equal to r cos theta and y is equal to r sin
R
theta.
sin theta.
Fine.
So this is the connection. Now what we will look at is some operations. These are called linear transformations. Some operations like what happens if I shift my coordinate system, right? So first we'll look at translation of axis, then we'll look at rotation, translation of axis, then rotation of axis, and then finally we'll look at rotation plus translation. Rotation plus translation. So what I mean by this is you should be comfortable moving your origin around. Okay. So let's try to understand all these three things. So suppose you have your origin here, right? And you have a point at this place, right? Point is 4 comma 5, right? Correct. Now there is another point Q which is 1 comma 1. Okay, this is O, this is P. Now what we want to say is some person was standing here and looking at the point P, right? And he saw that the coordinates of P was 4 comma 5. Now what happens if there is another person here standing at Q, right? So what is the coordinate of P with respect to Q, right?
3,
With respect to Q, correct? It should be obviously 3
3
comma 4,
comma 4.
3,
Yes,
4.
sir.
right? Because he sees distances as lesser than normal, right? He sees
Yes, sir.
this distance.
Who is the origin for
So you have moved the origin to this Q point, right? So every distance becomes slightly lesser, right? So in this new coordinate system, you have you have y dash and x dash, and x dash y dash will be equal to old coordinate system minus this position, right? X
Yes.
minus h, y minus k, correct?
Yes, sir.
So this will become basically 4 minus 1 and 5
5
minus,
minus 1. So 3 and 4.
2, 3, and 4.
correct. So what has happened here is basically a transformation. So you have moved from this origin to this origin. So this is how the change should happen. So what we have learned is new coordinate systems, let's say capital X will be old coordinate system minus new position, and capital Y will be old Y minus new position, right?
Yes, sir.
That is simple enough. Everyone can understand that, right?
Yes, sir.
However, now let's do this. Let's say we have 0 0, and let's say we have a line like this. Okay, the line equation of the line is x 2x plus 3y is equal to 6. Okay, so this point is basically 3 comma 0, and this point is 0 comma 2 line. This is a line L. Now the point is the same question. Now the origin has moved to this point. Okay, 1 comma 1, correct?
Yes, sir.
Now find the equation of the line in 1, 1. Now this is a new origin, okay? 1, 1 is the new origin Q. Equation of the line in the new axis, whose origin is 1, 1. Q is the origin.
So we can find out where it intersects the
Uh,
previous line.
you can find it out.
So we can find out the 2 points at which the
Hmm.
line 2x plus 3y equal to 6 intersects this new plane.
New line, new axis.
New axis is the new plane. So by finding those 2 points, we can find out the equation of the line.
Try and find it out. Just try and do it.
So this x-axis is going to be 1.
Which x-axis? This.
Sorry, the intersection point of the line along the y dash.
Okay, here.
Yeah, so that x-axis of that has to be 1 with respect to the old plane.
Yeah, that is true. It will be 1 comma, but you're again writing it in terms of the old things, right? See, if you write the equation, if you write this point in terms of old coordinates, no, then nothing will happen. No, then the same equation will come again. No,
Yes, sir.
Yes.
you understand? If you use old coordinates only, then how will you get a new equation?
So we can find the old, like using the old coordinates and accordingly translate it to the x 1, 1 format,
You
and
can
then
do that, yeah.
so that will be 1, if x is 1, that means that y is equal to 4 by 3. And
So it
if
is 1 comma 4 by 3, you're saying, in the old system.
in the old system, and for the other point of intersection,
Y will be 1.
y is 1.
So x is
So
3 by
x
2.
is equal to 3 by 2. So in the new system, since q is going to be 0, 0, then that is going to be 0,
1 by 3.
1 by 3, and that's going to be
1 by 2
1 by 2,
0.
0. And
So can
using
you
this,
find the equation of line between this and this? We can. So I will, if you don't know, I will just tell you. You know a line between 2 points, how to find equation?
I don't know any equation for it, but
if someone gives you the equation, you can verify, but you should also know how to write the equation yourself, right?
so you can find the gradient, which is
You can
basically
find the gradient.
y2 minus y1 by
x2 minus x1. So 1 by 3 minus 0
minus
by
0.
0 minus
Minus
half.
1 by 2.
So
Right.
1 by 3 divided by minus 1 by 2.
So minus 2 by 3.
Minus 2 by 3.
So if you write the equation as y is equal to mx plus c, let's say, right? You
So
already know m is
y-axis at 1 by 3. So immediately you can write y is equal to minus 2 by 3 x plus 1 by 3.
and
so
then
c
you
will be
can
1 by
put
3, right? Because it's intersecting y-axis at 1 by 3.
You are putting x is equal to 0 and 1 by 3 in this thing, no?
So c will be 1 by 3, right? So
Put x is equal to 0, c then 1 by 3, c will be 1 by 3. So y is equal to minus 2 by 3 x plus 1 by 3, right?
yes, sir.
Because the intercept you are saying, right? Y intercept is 1 by 3, that's why, right?
Yes, sir.
So the equation is becoming 3y plus 2x, right? 3y plus 2x is equal to 1, right? 3 times y
Yes,
plus
sir.
2x is equal to 1,
2x is
correct?
equal to 1.
This is the new equation, right? So the way you found it was correct, and that way was you found the points where it is cutting here and then converted into new coordinates and then find the equation between the line in new coordinates, right? Correct? However, we could have done this much easier, because in a much easier way, because we know that what happens to each x and y, right?
Yes,
What
sir.
happens to
So
every
X.
coordinate x and y, correct?
Yes, sir.
In the new translation, new equation, capital X should be equal to old minus 1, right? And capital Y should be equal to old minus 1, right? Again, correct?
So,
So small x is actually x plus 1 and small y is actually y plus 1. This is the old in terms of the new, right? Old in terms of
Yes,
the
sir.
new, right?
so can we replace that in the
Just
equation?
replace that here. So 2
So
times capital X plus
2x
1 plus 3 times capital Y plus 1 is equal to 6. So 2x plus 3y plus 2 plus 5 is equal to 1, right?
1.
This is what we got, no, right now also.
Yes, sir.
When we did our properly, when we did the points and all, we got this only, right? Makes sense.
Yes, sir.
So basically what is happening is, given any curve, let's say we have a curve like this, right? Okay, let's say the curve has some equation. I will write for now, I will write the equation as f of x plus y is x comma y is 0, right? What is the meaning of this f of xy? It just means that it is a expression, algebraic expression using x and y, right?
Yes, sir.
So if this was with some origin and you have changed the origin somewhere, right, to h comma k, right? So what happens is that capital X is equal to x, capital X is equal to x minus h, right? And capital Y is equal to y minus k, right?
Yes, sir.
So x will become x plus h and
X
y
plus
will
X,
become y
Y
plus k.
plus K.
Now, if I want to find new equation of the same curve, new equation of the same curve, in the new axis, then what you have to do is just replace the xy with.
So f of x plus h and y plus k is equal to 0.
So this expression will give you, after simplifying and all, this is the new equation of the curve, right? Correct.
Yes, sir.
Yes, sir.
Okay, so this part is fine. This is called a translation. Okay, so translation in the sense you're moving the origin to some other point, right? You're translating it to some point, correct?
Yes, sir.
Now we'll go to the second thing, which is called a rotation. Rotation is very important to understand properly. So rotation, what we mean is, let's say this is my axis, okay, and this was a point 4 comma 3, right? And this is my origin, and this is my y-axis, and this is my x-axis. Now what happens is, I have rotated my axis by some amount, right? Some degrees. So let's say my new axis becomes this, right? And the degrees that you rotate is theta, right? The angle by which you rotate it is theta. So this is my new axis and this is my x dash, right? Now the question is, if someone looks from the perspective of the new axis, what is the coordinate of the point P, right? So find P dash in x dash y dash axis, right? When P was 4 comma 3, right? And theta was, let's say, 30 degrees, correct? You understand the problem?
Yes, sir.
Okay, I will draw a slightly better figure. 1 second. Dave, you understand what to do, what you have to do.
Yes, sir. Understood.
So okay, this angle theta is 30 degrees, and this is my y dash, and this is my x dash. And point P is unchanged. Okay, point P is wherever it was originally only, right? It's just that you have started looking it from a new axis, right? So if earlier your distances your coordinates were this perpendicular distance and this perpendicular distance, right? Earlier, let's say that was called x comma y. Now the coordinates will be basically this perpendicular distance and this perpendicular distance. No, you understand what I'm saying?
Yes, sir.
Yes, sir.
Okay, so try to find this. So the approach here, I don't want you to find it by doing the distances. Okay, there are ways to do it using these perpendicular distances. I was just telling you what it meant. The nicer way to do it is by using polar coordinates. Don't try to find the distances. Okay, you understand that there could be a way by geometry to find this distance, right? And this distance,
Yes, sir.
but it is better to avoid that. It will be too difficult. What you should do is think of polar coordinates. So the point P could have been written as r comma theta, right? Initially, right?
Yes.
Yes, sir.
Or r comma alpha beta, let's use. Initially, let's say point P was written as r alpha, right? So the things that you know initially is that initial coordinate x should have been r cos alpha, and initial coordinate y should have been r sin alpha, right? Correct?
Yes.
Yes, sir.
Now think about what you have done. You have rotated the axis in this direction by 30 degrees, right? Correct? So
Yes, sir.
in the new, twist your head and look at it as if this was not present, the old axis. So if you look at it like this, the angle that matters for polar coordinates is this angle, right?
Yes, sir.
This is the angle that matters for the polar coordinate of P, right?
So, sir,
Yes, sir. 30 plus the original.
so yeah, it reduced by 30 degrees the angle by which.
The angle has reduced by 30,
By
alpha
30.
has 30, right?
Yes, sir.
If alpha was the original angle, then this angle is alpha minus 30, right?
Yes, sir.
So so in the new axis, I will write x dash as r. Is the distance going to change?
No, sir, because the origin is the same.
Origin is the same, so distance cannot change,
Distances won't change.
Distance
right?
won't change.
So r is the same, but angle has changed. It is now cos of alpha minus
Alpha
30,
minus 30.
and y dash should be r sine of alpha
Alpha
minus
minus 30.
30, right? This part should be clear,
Yes,
right?
sir.
Why it is happening, right? Now, do you know the trigonometric formula for cos alpha minus beta? Mansi, you
Yes,
know,
sir.
but Dave, do you know? You
No,
don't
sir.
know. Okay. So we will learn in trigonometry, or you can just read up SLONI. If you have for trigonometry, you can read up yourself also. It's fairly simple. You can find online also explanations. The formula for cos of alpha minus beta is cos
Cos
alpha
alpha,
cos
cos
beta.
beta plus sine alpha, sine beta.
Yeah. And the formula for sine alpha minus beta is sine
Sine
alpha
alpha,
cos
cos
beta.
beta minus cos alpha, sine beta.
Hmm. So, uh, Dave, these formulas are there in trigonometry in your SLONI book. If you have the trigonometry for SLONI, or also online, if you search, immediately you'll find how it is gotten, right? So it's not difficult. We'll come to it later when we do trigonometry. But for now, we'll be just using this result, right? So this part, right? So x dash is becoming what? R cos alpha cos 30, right?
Cos alpha cos 30 plus
Plus sin alpha sin
Sin
30.
Sine 30.
Sin alpha sin 30, and y dash is becoming R cos sin alpha cos
sin alpha
30,
cos 30
sin alpha
minus
cos 30
cos
minus
alpha sin 30.
cos alpha sin 30. So that actually will give you the thing, because now I will just rub off some space so that I can write this. 1 second. So think of what now you can write. Cos 30 sin 30 values you know already, right? So you can say x dash is equal to R cos alpha into root 3 by 2
Root 3 by 2.
plus
Sine
R
alpha by
sin
2.
alpha
By
into 1 by 2,
1 by 2.
and y dash is equal to R sin
R
alpha root 3 by
root 3 by 2
minus
minus cos
R
alpha.
cos alpha
R cos alpha
1 by 2,
1 by 2.
right? So
Yes, sir.
this is my x dash y dash final, and imagine that initial x was R cos alpha, right? Initial,
Yes,
y
sir.
was R sin alpha. So can you put x here?
Yeah, root 3x by 2 and yeah,
This is y,
1 by 2.
this is y, and this is x,
So root
X.
right?
3 by 2 x plus 1 by 2 y.
So now you can write your new coordinates x dash in terms of old coordinates, right?
Root 3x by 2 plus
3x by 2 plus
plus
y
y
by
by
2,
2
and y
and
dash
y dash
is
is root 3y by 2 minus
x
x
by 2,
by 2.
correct?
Yes, sir.
Yes, sir.
So in general, the formula comes as, there is a formula that is given in many books and all for this. I don't want you to remember the formula or try to remember the formula though, because it is very confusing. The formula is, if you rotate by an angle theta, right? If you rotate by an angle theta, then you have, 1 second, just hold on, let me try to recall the formula. So let's say a point P was there and it was having coordinates x and y in the original axis, right? Original axis was the regular axis like this, and the same point has coordinates x dash y dash in the new axis, right? And the new axis is obtained by rotating the old axis by an angle theta, right? Correct.
Yes, sir.
Yes, sir.
So then the result is you have this relation, x is equal to x dash cos theta minus y dash sin theta, and y is equal to y x dash sin theta plus y dash cos theta. Okay, now don't try to memorize this, it is annoying to memorize. Okay, don't try to memorize this. What we can do always, right, is always do it for ourselves, right? So we can say that x and y was equal to some r cos alpha, r sin alpha, right? Old coordinates, right?
Yes, sir.
So this was my old angle, right? Alpha, correct? And x dash and y dash should be r cos alpha minus theta, no? This angle, alpha minus theta,
Alpha minus theta.
and r sin alpha minus theta, right? Correct? Right. So
Yes.
using the formulas, x dash y dash becomes r cos alpha cos theta, and r cos alpha becomes x, right? So x cos theta plus r sin alpha sin theta, and r sin alpha is y, so plus y sin theta, comma, this becomes r sin alpha cos theta, so this is r sin alpha is y cos theta minus r cos alpha sin theta, so minus x sin theta, right?
Yes, sir.
Correct. So now notice that here I have gotten the result for x dash y dash in terms of x and y, right? However, this result has been written in the opposite way, right? X and Y in terms of x dash y dash.
X dash y dash.
Right? So how do we solve that? That is not very hard to solve. You just take the equations. X dash is equal to x cos theta plus y sine theta, and y dash
Y dash y cos theta
cos
minus x sin theta.
sine theta.
You solve that.
Multiply the top by sine and multiply the denominator by cos, right?
Hmm.
The second equation by cos, the first equation by sine. So what will happen is x dash sine theta
Sin theta
is equal to
equals
x sine
x.
cos, and this will cancel, right?
Yes, sir.
I'm going to add both the equations after multiplying. So x dash sine theta plus y dash cos theta is equal to, this part becomes y sine square and this part becomes y cos
Y
square.
cos square. So
Y.
y. Yeah.
See, this equation is the same as this. See?
Yes, sir. And now when you subtract, it will become.
So we get this, and when you subtract, is it cancel? No.
No, it's not.
No, so you have to do one
You
more
have to
step.
opposite. You have
Do
to do
opposite
cos
thing.
for the first one and sine multiply with the second. And
Cos
now when you.
now subtract, right?
Yes.
Now you have to subtract, right? So
Subtract,
x
yes.
cos theta minus y dash sine theta, right, is equal to, here it will be x cos square. So x.
And you, x, yeah.
Dave, are you understanding what we have done?
Yes, sir. Going.
So basically, the only thing that you don't know right now is the formula for cos alpha minus beta and sine alpha minus beta stuff, right? That is the only thing.
I know about trigonometric ratios, but I don't know such special.
So trigonometric ratios, normal stuff, you know, not till 10th standard.
Yes, sir, I know the three ratios. And
You have the SL book, trigonometry.
yeah, I have it, sir. Yes.
Okay, so start reading that book and start seeing what is happening. Multiple angles, sub-multiple angles, chapter 6, 7, 8 of that book onwards is what you have to start reading. Okay, and we will, if you have some doubts in that book, you can ask me in some of the future classes, whatever is the doubt. Okay, just start reading that book because that is important. Okay, we will not be spending time immediately on trigonometry because it is not so crucial. You just need to know some formulas, right? So you can read it yourself and understand. If you are facing issues, you can ask me, or you can go online and find out, right, what is the explanation. So for now, do you understand what we have done right now? We have transformed the coordinates, right? So we have rotated our axis, and this has become a new y dash and new x dash, right? And in this new axis, we have found the coordinates, right? Correct?
Yes, sir.
Yes, sir.
So think about what will happen if I had a straight line in the old axis, right? Suppose I had a straight line, and now the straight line's equation will be totally changed, no, in the new axis, right? The same straight line, right?
Yes.
So what is going to happen? Let's think about it. So let's say there is a straight line equation. This equation is x plus y is equal to 1, right? Okay, and now I rotate my axis by 45 degree. So now new axis is this, right? Correct?
Yes, sir.
So if you think about it, rotation by 45 degree will make it parallel to this line, right? Think through it. Why parallel to this line? Because this line was at this 135. This was, no, this was 45.
So that's at 45 plus 90, so that's 135.
So when you rotate it like this line should become now also parallel to this, no? See, this was my y-axis, this was my x-axis. Now new y dash is obviously parallel to this line, no?
Yes, sir.
Because see, corresponding angles are equal, no? This.
Yes, sir.
Right? So new axis in y dash and x dash is parallel, right? So if someone asked you standing here like this, that person, what is the equation of this line, right? Then you would have just said x is equal to something, no, this distance, right?
Yes, sir.
Yes, sir.
Right? So you would have, this person would have said equation of this line is x is equal to this distance d, right? And a second person standing like this here would have noticed the D very easily. He can find D, right? Because this point is 1 comma 0 and this point is 0 comma 1, right, in this straight line.
Yes,
So,
sir.
so this distance is root 2, right?
It's root 2.
So area of triangle is half into base into height, right?
Yes, sir.
Half into 1 into 1. It's also half into perpendicular D
So D into
into
root 2.
root 2.
Into root 2.
So perpendicular is basically 1 by root 2, right?
1 by root 2.
Right. So we know the D value is 1 by root 2.
Yes,
Correct.
sir.
So equation of the line according to this person who was standing like this and looking from this axis, right, should be x is equal to 1 by root 2, right? Right.
Yes, sir.
Is everyone understanding what I'm saying?
Yes, sir.
So the same line which had this equation x plus y is equal to 1 in this axis, after rotation, the equation has become different, right? Correct. So now what we will see is how to find the equation in general, because this person was able to say the equation because the line was so easy to say, right? Only because the line was easy to find, he was able to say the equation immediately, right?
Yes, sir.
If it was some more complicated case and it was not parallel, it would have been harder, right?
Hmm.
Correct. So in general, what we learned earlier is still applicable. So if you have some curve, this is a line in an old axis, and if you want to find line in the new axis, you have to replace x with the in terms of the old axis, right? And y in terms of the old x and y in terms of the new axis we have to replace. No?
Yes, sir.
See, earlier when we were doing in new axis equation of the line, right?
Hmm.
So we
Yeah.
replaced whatever was the old x, 3x plus 2y is equal to 6 was the thing, and we said x is equal to x minus 1 and y is equal to y minus 1, right? Plus 1, right?
Plus 1. Yes, sir.
Plus 1 and y plus 1, right? And we said x
We replace that.
instead of x we put that, and instead of y we put that, right?
Yes, sir.
And that's how we got the new equation of the line, right? In the same way, here after rotation, we will have a relation which I wrote in the previous screen, that x is equal to x dash cos theta minus y dash
Y dash sine theta.
sine theta, and
And
y
y
is equal to,
x dash sine theta plus y dash cos theta.
this is what I wrote in the previous page, right? Which is, this
Yeah.
is what we found out, right?
Yes, sir.
This is old coordinates in terms of new coordinates, right? So in the old equation, if I replace old coordinates with the new coordinates, I should get the new equation, right? So,
Yeah.
so let's just do that replacement. We'll get x dash cos theta minus y dash sine theta plus x dash sine theta plus y dash cos theta, right? Is
Yes,
equal to
sir.
1, right? And what was the theta? Theta was 45-degree rotation.
45. Yeah.
So theta is 1 by, cos theta and sine theta are both root 2, right?
1 by root 2. Yeah.
1 by
1
root
by
2.
root 2.
So x dash 1 by root 2 plus x dash by root 2 minus y dash by root 2 plus y dash by root 2. So cancels,
Cancels. Yes.
is equal to 1, right?
1.
So
Yeah.
this becomes 2 times this. So root 2 x,
Root 2x dash is equal to 1. So x dash is again 1 by root 2.
which is what we got by common sense and geometry, right?
Yes, sir.
Yes, sir.
This is by geometry we got by thinking about the figure and all. This is by algebra and coordinate geometry we are getting, right?
Hmm.
So
Yes, sir.
the idea is basically that given any curve, right? If I do a translation, I can find a new equation still. Just replace this curve with f of x. If it was a translation to this point, it will be x plus h
Plus h and y plus k. Yeah.
is equal to 0. Now, if it was a rotation of the axis, right? The same curve will become different and it will become xy is equal to 0 will become, instead of x, I have to write x dash
cos theta
X
minus y dash sine theta.
sine theta, comma, I have to write x dash
Y
sine
is x
theta,
dash sine theta plus y dash cos theta.
right? And this is the equation for x and y in terms of the new coordinates. If you
Yes,
rotated it by an angle like this, notice that this equation is true only for a rotation in the anti-clockwise sense.
Yeah, anti-clockwise.
Because only if you do it anti-clockwise did your angle reduce, no, finally. This
Yeah,
angle
it
became
became
alpha
minus theta. Yeah.
If your axis had gone the other way, right, the angle would have been bigger, no?
Yeah, it would have increased.
If
theta
you
would
had rotated in this direction, your angle would have been alpha plus
The
theta.
plus theta.
So the formulas would be slightly different, right? In that
Yes,
case.
sir.
So what I want you to do is not try to memorize this because you can make mistakes in memorization. What I want you to understand is how we got the rotation method, right? So you took a point, wrote it as r cos alpha, r sin alpha, and later after rotation, you noted that r cannot change. So it will become r cos some alpha minus beta and r sin alpha.
Sine of alpha minus beta.
alpha minus beta.
And it could also be al cos alpha plus beta if your rotation was opposite direction,
Opposite sense.
right?
Yeah.
So this will be your final coordinates, so which will be x dash comma y dash, right? And this will give you x dash y dash in terms of old coordinates, right? Which was x and y, right?
Yes, sir.
Because when you expand this according to your formula from trigonometry, what you will get is cos alpha, cos beta, and stuff, right?
Hmm.
So you'll get r cos alpha, which is x, and r sin alpha, which is y.
This is y, and then we write it in that terms.
So you'll get x dash y dash in terms of x and y. But when you need to transform the equation here, you cannot use this formula directly, right? Because the equation is in terms of old coordinates, right? And this
Yes.
formula is in terms of new coordinates,
New coordinates.
right? So you have to actually do the opposite operation by solving it, right? So remember, we had to solve the equation to find old in terms of new, right? Right now,
Yes, sir.
what we have here is new in terms of old, right? Dave, are you understanding?
Yes, sir.
New in terms of old equations will come, and then just solve the two equations to get old in terms of new, right? Once you have that, then you can put it in this formula to get the new curve equation and stuff, right? So we will not do anything more. Rotation and translation we have understood. What I would like you guys to do is SL Loni chapter 7 coordinate geometry book. Okay, chapter 7 is called transformation of coordinates. Transformation of coordinates. That chapter exercise 15 you can try. There is an exercise called examples 15. Okay, so in that there are some 8 questions. You can try those 8 questions. Okay, there's not too much. There are 8 questions. Exercise 15. Okay, so that is transformation of coordinates. And what we have not done, the third case, is basically combination of both the things, right? It is rotation plus translation. So let's
Yes,
say
sir.
your axis from here, it became like this here.
So D1 rotated and it translated also.
So first, either do rotation first and then translation, or you do first translation, bring the origin here, and then rotate.
But that will produce different figures.
No, it will be same thing. I mean, different figures.
So if you translate first and then rotate and then rotate and then translate.
Not going to change. These
It's
are
gonna
both.
be same only.
So when you're rotating and then translating, you're translating in the on the base coordinates on the basis of the previous one.
No, so you can rotate like this first only, right?
By same and then just okay.
And then move it here. How is that different from moving it first here and then rotating? It is
No,
not
so
at all
I
different.
got a different thing.
You understand?
Yes, I got that.
So any point here P, right? Whether you do what first doesn't matter. Okay, so rotate and translate, or translate and rotate, whatever is convenient. So we will discuss 1 or 2 cases of this in the next class. Okay,
But so what I was thinking is that you're translating after rotating in the terms of the new axis, but you're translating in the terms of the old axis, so it will remain the same.
Okay. But as long as you understand that these operations can be combined in any combination, rotation, translation, they can be combined is in any combination, and the effect is the same if you change the order. Order doesn't matter here. Okay.
Yes, sir.
So finally, point P coordinates in the new system will be the same. You should get the same coordinates. So you can experiment with a few angles and few things, what should come and all. What we will discuss it briefly in the next class, in the maths class. Next class might be physics. So tomorrow you guys are free, right? Tomorrow evening. Generally, the plan was Saturday, Monday, Wednesday. So let me know on the group if you guys are free tomorrow evening.
So around what time, sir?
Around 5:30 or 5 o'clock. That is
Yes,
the
Yes, sir, that should be fine.
that's fine, sir.
okay. So 5 o'clock maybe, or 5:30, whatever is convenient. Yeah.
Yes, sir.
Yes, sir.
Okay. So that will be physics. So we'll do maths, physics, maths like this. Okay.
Yes, sir.
So SL Loni book, try this chapters, read through chapter 7 first exercise, till the first exercise. There are only 8 questions. Okay. So everyone should try it. Okay.
Yes, sir.
Yes, sir.
Okay. That's it for now then. I'll see you tomorrow.
Yes, sir.
Okay. Bye.
Thank you,
Thank
sir.
you, sir.
Bye, sir.